All right, in this video, we're going to be sketching the graphs of logarithmic functions that have multiple transformations going on. So in this first example, you can see we're trying to graph 5 multiplied by log base 4 of x plus 2. And then we'll find the domain range and asymptote. And then we'll do a second one here where we have 3 multiplied by log, common log, so log base 10 of x minus 2 with a plus 1 outside. Again, we'll find the domain range and vertical asymptote. So as we get going on these, what I always like to do is start out with a nice parent function, and then we'll apply one transformation at a time. So our parent function on this one is going to be log base 4 of x, which has these two key points. It's always 1, 0, and then the base, comma 1. So as you can see, our base here was 4. First transformations I always like to approach on these are any multiples attached to the entire function. So in this case, we're going to call this multiplying by a 5 as being a stretch because it's a multiple bigger than 1. If that had been a 1/2 or a 1/3, something like that out in front, between 0 and 1, we call that a compression. So what that's going to do to affect our graph is basically we've represented our y values as log base 4 of x. So what's happening to all the y values is we're multiplying each one of them by 5. So using these two key points that we already know on our graph, I'm going to multiply the y value from each one of these key points by 5. That'll give us points on our new graph, the 5 multiplied by log base 4 of x. So the first one, we have 1, 0. We multiply the 0 by 5, we still get 1, 0. However, the second ordered pair here, the second key point, 4, 1, as we multiply that y value by 5, it's going to go to 4, 5. Right, 1 times 5 makes 5 for that new y value. So the look of our graph is going to be much taller than the original. It's been stretched out. So it's going to take on more of that look, just hit up the key points that we've already identified. Okay, the next thing we would like to do on this one is apply this +2 transformation. Now that transformation is attached directly to x, so we know whenever you attach a transformation directly to x, it's going to be a horizontal shift of some sort. Horizontal shifts kind of work in the opposite direction as we think they should. They're kind of counterintuitive. So what's going to happen on this one is it's going to move everything to the left 2 units. So the first thing I'm going to move to the left 2 units is our vertical asymptote. You'll notice that on our previous graph, we have a vertical asymptote that's at the y-axis. That's when x equals 0. That's going to get picked up and moved 2 units to the left. So it's going to land at -2. I'm going to identify that with a vertical dashed line. Typically when it's on the y-axis or on an axis, it doesn't get the dashed line, but as soon as you move it over off the axis, that's when we use a dashed line. Okay, the next thing I'm going to do is I'm going to move these 2 key points to the left 2 as well. So we had one that was at 1, 0. That's going to move 2 units to the left. So that's going to go over here to -1, 0. The other key point was at 4, 5. That 2 is going to move 1, 2 units to the left. So that's going to be at 2, 5. Go ahead and label those, and then we'll connect the points. And what this should look like is the exact same graph as what we just have on the left-hand side, like this exact same curve going on, but picked up, moved 2 units to the left and set back down. All right, to finish this up, we've already identified the key points on this graph. If I were needing to graph this in the system, in any homework system, I would click, make sure you have the logarithmic function graph pulled up in the toolbar. As far as the vertical asymptote goes, that's going to be at x equals -2. The range on all of these logarithmic functions is always going to be negative to positive infinity. And then the domain, hopefully we can view on this, it's everything to the right of -2. So we can indicate that as -2 to infinity. Leave out the -2 because that's where we have a vertical asymptote. All right, one more short example on this. We're trying to sketch 3 multiplied by the common log of x minus 2 with a +1 attached to the entire function. So pretty similar as far as getting going on this. The parent function here is going to be our common log function, which remember is log base 10. So our key points are always 1, 0, and then whatever the base is, comma 1. Vertical asymptote going on at the y-axis for the starting function. Next, let's start applying a few transformations. I always like to start out with any multiples attached to the entire function. So when you have a multiple attached to the entire function, it's either going to be a stretch or compression based on if it's bigger than 1, like this one, we're going to call it a stretch. If it had been a multiple between 0 and 1, again, that's a compression. So how these affect our graph is you're going to multiply each one of the y values from our key points by whatever this multiple is out in front. So our key points in this case are going to go with still going to be 1, 0, as 0 multiplied by anything is still going to be 0, but then 10, 3. Okay, it goes 10, 3 because we multiply that 1, our y value here, by 3. The stretch out in front, that's going to produce the 10, 3. This does not affect our vertical asymptote, so it's still in the same place. Kind of connecting these points together, doing our best to hit these points. And our graph's going to look a little bit taller than the original one, 3 times as far away from the x-axis. For each one of these points that was on the original graph, that should become 3 times as far away. All right, next up, let's go ahead and apply this next transformation. We have this +2 attached directly to x. So when you attach a number directly to x, that's either going to be left or right. It's going to be some sort of horizontal shift, but these kind of work in the opposite direction we think they should. They're counterintuitive. So subtracting 2 is actually going to move everything to the right 2 units. So I'm going to take these key points and I'm going to add 2 to each one of these x values. So we were at 1, 0. So that's going to move to the right 1, 2 units. So that's going to put us at 3, 0. And then we were at 10, 3. We're going to move to the right 2 units there, 1, 2. And that's going to be at 12, 3. All right, everything else just kind of comes along as far as our points go. We haven't moved it, sorry, let's get that corrected. We moved everything to the right 2 units. That should include our vertical asymptote. So let's be careful about that. It was at the y-axis when x equals 0. It too needs to move to the right 2 units. So when we put that back down, it's going to be at x equals 2. I'm going to indicate that with a vertical dashed line, by the way, because it moved off the axis. All right, now getting everything else in place, we're just going to kind of connect the dots, make sure we stay to the right of that vertical asymptote. And then one last transformation here. We have a +1 attached to the entire function. When you attach a number to the entire function, it's going to be a vertical movement of some sort. They work the direction you think they should, though. So this is going to move everything up 1 unit. So again, track around our key points as well as that vertical asymptote. Moving everything up does not move our vertical asymptote, so it's still going to be at 2. So again, I'm going to include a vertical dash line here at 2. But then it is going to pick up each one of these key points and move them up 1. So instead of 3, 0, it's going to move up 1. So it's going to be at 3, 1. I'm adding 1 to each one of these y values. And then 12, 3 is going to move up 1. That's going to go to 12, 4. Keep track of those key points. Everything else should track along and just move up as well. But focus on those key points. I find that to be the key to getting really good graphs on these. All right, now looking at that graph, we did say our vertical asymptote had moved to the right 2, so that's going to be at x equals 2. The range on every one of these is going to be from negative to positive infinity. And then looking at the graph, you can see that our graph is just to the right of that vertical asymptote. So we would define that to be from 2 to infinity. We're going to leave out the 2 and the infinity. All right, hope this helps as we're trying to apply transformations, multiple transformations to logarithmic functions. Good luck.